Aviators, Captain Dwight with you. I have an important lesson for you today on angle of attack. You're going to hear this term quite a bit in your flight training, angle of attack. Well, let's discuss it and see what this is all about. Let's take a look at this wing back here. Two terms that you're going to need to know before we really get into angle of attack. We have to know, what are we measuring? Well, if you look at an airfoil, a wing, we have the leading edge and the trailing edge. If we draw an imaginary line from the leading edge to the trailing edge, imaginary straight line, we call this the chord line. Then we have the relative wind. Now the relative wind is the direction of the airflow produced by an object moving through the air, in this case the wing. The relative wind for an airplane in flight flows in the direction parallel with and opposite to the direction of flight. Therefore, the actual flight path of the airplane determines the direction of the relative wind. Now, this is important that you understand this right here. Relative wind do not confuse it at all with the wind that you feel out when you're out on the airport. You can have a 50-mile-an-hour wind, but that will not affect the relative wind. The relative wind is created by the wing traveling through the air. All right? So our angle of attack is this angle from the direction of the relative wind with the chord line. Okay, now here's where it gets important. You know that as we go faster, travel faster in the airplane, we increase our thrust until we get to maximum speed, where we don't have any more thrust available to get us going faster. To stay at straight and level flight, let's say at 2,000 feet, we would have to reduce our angle of attack. Otherwise, the airplane would lift. If we have all that air flowing over it, it wants to create lift. So we have to reduce the angle of attack. If we slow the airplane down, let's say to 50 knots, that's getting pretty close to its stall speed. Well, we don't have as much air going over the airfoil, over the wing. So we're not going to create as much lift. So what you have to do is you have to coordinate the angle of attack. So we would increase the angle of attack the slower that we fly. Now let's take a look at how this works in the simulator. Okay, here we are level at 2,000 feet. I have full power. You can see I'm not real good at this. You guys are probably better at controlling this airplane than I am. But anyway, here we go. I'm got to have it pretty smooth now at 2,000 feet. Full power. We're doing about 110 knots. Now, let's say that, and you can see the picture of the airplane over here. Now, let's say that I just chop the power. Okay, that's going to reduce the air going over the wing, so you can see I start to go into a decline, and so I'm having to pull back on the stick to change the angle of attack as the airplane slows down. You can see the airspeed over there with 90 knots. Whoop, I'm starting to lose altitude here. Let's see if I can keep it steady. I want to keep it right at 2,000. Let's say 1,900 will be my number. You see we slow down. Now you can see the airplane over here, how the nose is having to go up. The wing is having to, the angle of attack is having to increase for me to keep this thing level. Now we get to a certain point, which is called the critical angle of attack, and then we lose it. See, now I'm in a stall. So what do? Give it full power, get our airspeed back up. So you can see that reducing the airspeed reduces the lift. And so I have to pull back on the yoke. I have to bring the nose up. I have to increase the angle of attack to keep my same altitude as my airspeed slows. And then, of course, the opposite is true. If I'm traveling at a slow airspeed and my angle of attack is going to be high, as I give it throttle and increase the thrust, increase the airspeed, that extra air going over the wings will give me lift. So if I wanted to stay at a constant altitude, I would have to decrease my angle of attack. Aviators, on a couple of the questions dealing with angle of attack in the FAA database of questions, I have noticed in the answers, a couple of the possible answers reference two other angles. And I want to discuss what these angles are so you won't mistakenly choose that one of these. The first one we'll discuss is the angle of incidence. Now we have our chord line, which is referenced by the red line here, and an angle to this blue line.
Well, the blue line in this case is the longitudinal axis of the airplane. You recall we discussed that in a previous lesson, and it runs from the nose of the aircraft to the tail. Do not confuse the longitudinal axis and the angle of incidence with the angle of attack, which is the chord line to the relative wind. The second possible answer that you might see is the dihedral angle. That is the angle from the horizontal line to the actual angle of the wing of the aircraft, as you can see right here. Now we'll get into the purpose of the dihedral angle in a future lesson, but you do not want to confuse this in any way with an angle of attack question. This completes our lesson on angle of attack. Fly safe.